Hi, I'm Paul Brodie. We're back in my shop. There's a man behind the camera. The man behind the camera has a new camera. So let us know if the quality is up, down, whatever. Welcome. We're building an Aramaki race bike, and I thought I would tell you a quick story about how I got involved with Aramaki race bikes. I owned an Aramaki, that's the black one you've seen in the videos, and looking through Aramaki books, I knew that there was a race model available, and it had the frame with the plates on the side, and me, as a frame builder, I thought that was pretty cool, so I wanted one. I just wanted to have a frame, so I figured the easiest way to make a frame was to get a frame jig made. And so I got introduced to Trev Dealey of the Trev Dealey Museum, and I asked him the big favor. I said, you have an Aermacchi 250 race bike, would you lend it to me? Because I want to take it back to my shop. I want to take it all apart and have the frame, make a jig, and then I'll make my own frame, and then I'll put it all back together again, and I'll bring it back to you. And he looked at me and he said, how long is that going to take? Me being the optimistic person that I sometimes am, I said, oh, a couple months. And he said, okay, well, it took 6 months, but I did that. I brought the frame back, took it all apart, made a jig, took it back to him. And then I made my own frame. And as soon as I made my own frame, I realized I have to put parts on this. So I started assembling wheels, gas tank, and all that. And then I realized that I got to do something with this. So that's when I decided to go road racing. So it was never my plan to go road racing when I started the frame. I just wanted to build a frame. So you can see how one thing leads to another. And then I signed up for race school. That was 1999. So let's talk about the project here for a little bit. Last time I told you that I was going to work on the brake cam. We had to cut some splines. So I think Mitch has a photo of the 3 splines that aren't cut. It's just like a flat, it's a radius. So I went to my metal shop and I found that I can buy a tool for $42.81, and it would take a couple days, 3 days to get in from the east. So I figured that's kind of a lot of money just to cut 3 splines. So I thought, what else can I do? So on my lathe, I've got an internal threading tool. That's this. And I found that it'll mount in my mill. So I set this up. Actually, first of all, I set up this piece here and I cut just some splines to make sure this would work. And it did work. So then I made up, I don't know what you call this, a collet of some kind. It's a piece of aluminum tubing and it fits nicely, and it's got a slot from the hacksaw so that when you put it into a 3-jaw chuck like on the rotary table, that's basically how it works. And when Honda makes splines, they don't do an even number, they do 31 splines. So you divide 360 by 31 and you come up with an angle of 11.613 degrees. So that's how much it had to move each time to cut each spline. So I did that, that worked out really nicely. I also drilled a hole right through the middle, saved 1/2 ounce of weight, that was cool. So this is the backing plate that I worked on last week, and you can see that I've smoothed it out. This is all manual machining, there's no CNC here, so it's kind of hard to get the blends just nice, so it's not bad. I screwed up here, so I have to fix that. I did a boo-boo. Somehow the tool hit there. I was using a radius tool, and I still don't understand how that happened because this is lower than this, but somehow it happened. What we're going to do next, we're going to make an air scoop. So it's going to come in here. This is extra metal that has to come off, and then it's going to come in here. So we got to hold it at an angle of 30 degrees. I did my drawing, a sketch. This is like that, and you can see the air scoop's going to come in like so, and I want it to come in, see this is wide here, I want it to come in at an angle, so I made up a fixture. So this plugs in here like that. I've got an 8mm Allen screw. And then I scribed a red felt pen. So that's going to get held in the vise. And that sets the angle. So that when we come in here with a drill and a mill or whatever we got, it's going to make it the right angle. So that's the menu for today. We're going to head to the mill. Thanks for joining us. That's pretty good. Okay. So we're going to drill some holes down there and see how that works out. I've never done this before. There it is. Okay. All right. Oh, there we go. See, the problem here is that the end mills I have aren't overly long. I can plunge it down though. Let's see what happens if I plunge it down. There we go. Oh! Oh well, that's all extra metal. That just shows that this isn't holding as hard as I wanted it to. That's the problem when you're holding something out as far as that. Like even though I made the vise tight, have a look here. See how it even moved. It moved on my line there. So I have to take small cuts. That's what it means. Smaller cuts. And that vise, I made that pretty darn tight. So, okay. And I have to make things even tighter. There we go. I think I'm going to do all the rest of it. It'll be done by hand. I've got a porting tool, powered. I'll just work away at it. So let's take it off and see where we're at, and then we'll start working on the outside. I think that would be a good thing to do now. I've got a porting tool, and this is going to go inside. See how this is long, and I've got other bits as well. These are called burrs, carbide burrs, and so this will all get smoothed out, made to look nice. I'm not going to do this right now because that's a few hours of work, but I'll just start the process and you can see what's going on. I got the foot control. So what I'll be doing is this. I think you get the idea. I'm going to be here for a little while, and after that, I'll take some emery cloth, make it all smooth. So that's the tool. I have to put a couple mounting holes in here because there's going to be a little air scoop here, and if you look on the other backing plate on the front wheel, there's a couple little Allen screws holding on a piece of sheet metal, so I've got those lined up. I have to figure out where I want the hole, so I'm gonna drill and tap a couple 5mm threads. That's next, and then I'll figure out what shape I want, because this all has to be milled down. It's got to come, this all has to come way down. So I'm going to put one thread right there. And the other thread is going to go right. So this is going to be raised up. This is going to be raised up for the scoop. Comes down 5/16. And then that's going to be raised up, and there's going to be a rib and a rib. I'm out of breath a bit from this. Okay, so it's taking a very little cut there. I'm calling that 0. So we're going to take a 100th cut at a time and go basically over the whole thing. It's not firm in my mind how this is all going to fit together yet, so it's kind of evolved as I make it. That's kind of how I do things. So we're going to leave that bit there, and then it can get radiused at the end. I got this tool. So a lot of what's going to happen on here, we're going to use a ball end mill to make a nice radius. So this is going to have a radius around it. After I put this back in the lathe, I'll use a radius tool. That'll be radiused, and there'll be a radius around the brake cam boss. So a few radiuses in mind. We also have to drill holes after it's milled down. There's going to be, I think, 3 holes here, like that. Okay, we're going to do some more milling. So I need to leave some metal here. It's got to come down more, so we're going to go like so. And then there's going to be a raised up, a little bit of a raised up boss here. Nice circle, Paul. And then another rib coming down here. So those areas we have to avoid, and I can't figure out if I should go in like that or leave a space like that and leave this thick. Maybe I'll leave that thick. I can always change it later. See, this has to come down to this level here for the boss anyway, because that's where the brake cam goes through, so it doesn't want anything on the outside there. And then we have to figure out how much more this comes down. I'm going to show you how we figure out the thickness. Is a pretty handy thing because you can put it in a place that's hard to measure. And if you notice that I've worked on this and I've tried to make it as accurate as possible. When this closes, that closes too. So if this closes on something like, let's say this, let's say I do it there, I can actually measure this, and I can get this size within a few thou. So this is a pretty handy thing. We're going to use this on the inside here because we don't want the backing plate to be heavy. That's the last thing we want. It's got to be strong, but it has to be light too. So why don't we take it off and see how much it's going to come down. Put it like that. 845. I think a 1/4 inch in here. Okay, so let's go take off a bit more metal. Just a little bit more. Okay, so we're going to mark out an area around the boss, something like that. I can mill off all of this area now and come into here, but I can't go, I can only do up to this line, these lines here. So that's this is my access here to go into here if I don't want to move the tool up and down. Okay, 327 or 329. So if I take off another 75 thou, that'll bring it down to 1/4 inch, and then I've got the rib for the reinforcement on the side. So that should be okay. So 75 thou. Take this off. I think I want to weigh this now just to see how light we've got so far. There's still more to come off. Honda backing plate, 772 grams. We just took this off the mill. Oh, it's a bit heavy. And I said to Mitch, I said, how much do you think this weighs? And he said, what did you say?
1,200.
He said 1,200 grams. And I, being the optimist, I said 950. But it's 1,236 grams, so we still have a lot of metal to dig up. That was a good guess. Very good. Yeah, we got a lot more metal to come off here, so we're going to save some more weight. That's my spigot, and it's going to go like that. I'm going to take a radius tool, and we're going to make this smooth in the lathe. I got a radius tool. It's a 3/16 radius tool, so 3/8 overall. And we're going to make this all smooth, and I'll use an indicator to set the depth. All right, so I'm basically at the same height now as the boss. So I need to go down more so that this ends up at this level here. And then I'll take more off this in the mill, another 300 thou. I'm going to change tool bits. Okay, so we're down, we're very, very close. That could get polished out. Gonna switch tools now and put the radius tool back on and flow this in. Oops, too much. Always good to spin and make sure everything's free. See how I took a little chunk out there? I had it too close because the tool was sitting on the flat. So if you spin it with your hand, you know it's free. That's a good place to start. So we're going to put this back in the mill now, and I'll mark an outline, and we're going to take off another 300 thou here. So that's the shape we want to do. We want to take off 300 thou. All right. What I'm doing here, I'm going to mill down this so that this surface here is flat. And I want this surface to meet this surface, which has been turned on the lathe, because that's the tangent of that circle. And then once I've established that, I might have to move this back and forth a little bit. Then I'll go inside with the ball nose end mill, and then I'm going to mill along here so that this milled part inside is parallel with the outside. That's going to look best. And then I'll figure out what sort of a thickness I want here. Maybe, I don't know, 3/16 of an inch, a 1/4 inch, something like that. I'm just winging it basically, but I've had a little experience, so hopefully it works out. So I'll set my height there. Okay, let's see what happens here. It's touching. Yep. It made a tiny little flat spot there. So now we'll go back and forth and take off cuts, and this is gonna make a nice radius. So let's see what happens, and I'll try not to put a flat spot on there. Oh, look at that. That's the flat spot. So basically, it's looking good. Okay, so we'll do the inside now. I'm going to use the ball end mill, 5/8. We're going to take off metal from here around like that. And probably, as long as I have the boss there, that's good. So probably like that. And then if I need to take a bit more off later, I can. For now, we're gonna take off that, and we're gonna smooth this into here. Gonna lose all that. We're going to drill some holes now, and this is my highly accurate, super way of figuring out where the hole should go and how much. So we're looking at this, and we go, oh, about halfway like that. And then we draw a line. I think I want 3 holes. I think I have enough room for 3. And then we look at the space we have here, and we go, well, that's 1.1 inches. It could come out almost that much. I'm going to get a piece of 1.1 inches, and this is away from the surface, not very good. I found a piece of metal. It's, well, it's 1 inch, but it's going to be enough to draw a circle. Maybe the holes will be 1 inch. I thought maybe 1.1 inches, but this is the mock-up to see what it looks like on the inside. See there, I think we have enough room for 3 holes. Could use an 1-inch hole saw. That'll be an easy way to pop it through. Looks like that's the center. This is just eyeball, but it's just a hole to save some weight. That's where the hole would be. It kind of looks like it wants to be this way a little more. We could do it like there. That would look better. So that's going to be the center right there. Set it to 0. We're at 2.892, so half of that is 1.445. That's pretty close. So if we do it like that, that's our center lines. Okay. Let's go drill some holes. Now I'm going to switch. See what happens here? I'll show you. See how the aluminum clogs up? That's why it doesn't want to go down any farther, because the aluminum's clogging it up. And that's how you find center, when the drill doesn't flex from one side to the other. Then you found center. Okay, now we have to use the boring bar just to make them smooth. Now I have to center it with the tool bit. It has to overlap each edge just a little bit. So there we go, we got a little overlap, and that's a little bit more overlap. That's about right. last time we weighed this, it weighed 970, and now we've drilled some holes and maybe done a little bit of other stuff. So Mitch, you had an idea of how much? What did you say?
850.
850. I'm going to say 910. And the weight is 917. So anyway, that's the backing plate. It's not finished, obviously. I'm going to work on it this week, but that's the basic shape. It's going to get smoothed out a bit, maybe a little bit more weight taken off here and there. So I hope you've enjoyed watching this whole process. It's a little bit complex, I think you could say. Thank you for watching. We appreciate it very much. Mitch and I like coffee, you know that. See you next week. Stay safe. Have a great week.